Hi, Jeff Prosize here to talk about Azure Machine Learning. Machine learning facilitates the analysis of large volumes of data by employing algorithms that iteratively learn from that data. It's one of the fastest growing areas of computer science, and it's used to perform predictive analytics in the era of big data. Its uses range from credit card fraud detection in self-driving cars to optical character recognition and even online shopping recommendations. Indeed, when you drop an item into your shopping cart at Amazon.com and you're presented with a list of other items you might like to buy, Amazon is using machine learning based on what you put in the cart, the items you've purchased in the past, and what other people with similar buying patterns have purchased to make recommendations to you. It makes us smarter by making computers smarter, and its usefulness will only increase as more and more data becomes available, and our desire to perform predictive analysis from that data grows too. Azure Machine Learning is a cloud-based predictive analytics service that offers a streamlined experience for data scientists of all skill levels. It's accompanied by the Azure Machine Learning Studio, also known as ML Studio, which is a browser-based tool that allows you to build models using simple drag-and-drop gestures. It comes with a library of time-saving experiments and features best-in-class algorithms developed and tested in the real world by Microsoft businesses such as Bing. And its built-in support for R and Python means you can build custom scripts to customize your model. Once you've built and trained your model in the ML Studio, you can easily expose it as a web service that is consumable using a variety of programming languages, or share it with the community by placing it in the Cortana Analytics gallery. In this hands-on session, I'm going to spend a few minutes in PowerPoint introducing the basics of Azure Machine Learning. And then I'm going to put away the PowerPoint slides, open ML Studio, and build a model from scratch. You can follow along with me if you'd like to build that exact same model. It's a great way to get acquainted with Azure Machine Learning in ML Studio, and then you can use that model or build others like it to perform predictive analytics of your own. So what is Azure Machine Learning? Simply put, it's a cloud service for building sophisticated machine learning models, often without writing any code to make those models work. Think of it this way: if you were building a machine learning system from scratch, it might have two inputs: the data that you're feeding into it and the code that you did to implement the model. Then you feed the data in, your code executes, and you get output, predictive analytics out. With machine learning, we don't write that code. We let the machine do the learning in an iterative fashion. In essence, we give it input data and we give it output data that it can score itself against, and the machine does the programming so that when we present it with additional input data, it can use the model that it's already built to predict the outputs. One of the cool things about Azure Machine Learning is that it lowers the bar. You don't have to be a programmer, and you don't have to be an expert in data science in order to build sophisticated machine learning models. You'll use a tool called the ML Studio, pictured here in this slide, to build these models, to build the workflow, by dragging and dropping modules from the modules palette on the left out onto the canvas on the right, and then building workflow by connecting those modules together. Now, when you do ML, you code up algorithms, or at least you would be coding those algorithms if you were building it from scratch. With Azure ML and ML Studio, commonly used machine learning algorithms are already built into the package. In fact, they show up in the modules palette. There are algorithms for doing classification, regression, anomaly detection, and more. I'll say more about those algorithms in a few moments. But if one of those algorithms that's in the box doesn't fit your needs, you can always use R or Python to code up the algorithms of your choice. When it comes to inputting data into Azure Machine Learning, and specifically into ML Studio, it supports a lot of different formats as input. It supports plain text, CSV, TSV, OData, RData, and more. And if you want to input data in a format that's not supported out of the box, you can write something called a reader module to bring that data in from other places. One question I'm commonly asked is, how do I get data from an Excel spreadsheet in ML Studio? Well, one way to do it is to write a custom reader module that will read that data directly from the Excel spreadsheet. But what most people do, because it's easier, is they export the spreadsheet into CSV format, that is common or limited text format, and then they simply import that data into ML Studio. If you've never seen machine learning at work, here's a website that you might find interesting. The URL is how-old.net. It's a website that's owned and maintained by Microsoft, and its purpose is very simple. It allows you to upload photos of people, and it attempts to predict how old the people in the picture are. Now, it uses a combination of machine learning based on regression analysis with some fairly sophisticated image detection techniques to find the faces in the photos and to pull out characteristics of those faces in order to predict how old that person is. Now, this is an old photo of me. I don't remember exactly how old I was there, but 45 is within a year or two. It's pretty amazing. Try it. Upload some pictures of yourself, your kids, friends, and family members, and generally it will get within a year or two of the age of the people in those photos. This quotation comes from a grad student that I recently met at a university here in the United States. I was doing a talk on Azure Machine Learning and led the people in the audience through some exercises using the ML Studio. And afterwards, this young man walked up to me and he said, "You know, I spent last semester building an ML model based on regression in Python. It took me most of the semester to do it, and I just built the same model in Azure ML in 10 minutes. That's what Azure ML is all about. It's software as a service. You don't have to write the code to build a model. You're letting the machine build that model for you. And you're using ML Studio to make it really, really easy to do that. This is the face of modern machine learning, where instead of focusing on the implementation of the model, you can focus on the data and let the machine build the model for you." The science of machine learning has been around for a number of years. Azure ML is fairly new, but that doesn't mean that this is Microsoft's first rodeo. In fact, Microsoft has been involved with machine learning as a data science for a long time. Here are some examples of how machine learning has been used in Microsoft properties and Microsoft products, dating all the way back to 1999 when Microsoft bought a Silicon Valley company and created Hotmail from it, and they implemented some fairly sophisticated spam detection algorithms using, you guessed it, machine learning. Now, historically, again, in machine learning, you have to code these things up. You have to build the models, implementing them from the ground up. But the beauty of where we've evolved to today with machine learning is that with tools like ML Studio, you no longer have to implement the model. You let the machine implement the model for you. Here's a diagram that demonstrates how we typically go about building a machine learning model. And specifically, it's the workflow that we'll use to build and train and score a model in the Azure ML Studio. It starts with the data. This is the data that you provide to the model for input so that it can learn from that data and later perform predictive analytics when you provide separate inputs to it. The more data you can provide, the better. Once the data is in the model, it typically needs to be prepared or cleaned or pre-processed in order to be fit for machine learning. You may bring in a data set, for example, with hundreds of thousands of rows, and some of those rows may contain missing values, and you'd like to factor those out of the data fed into the model so that they don't skew the learning. As you'll see, with Azure ML Studio, there's several different modules that we can choose from, modules for cleaning and preparing the data in various ways, so that we can present the best data possible to the model itself. Once the data is ready, then you begin working on the model. First step there is to choose a machine learning algorithm. As you'll see in ML Studio, there are several to choose from, and this is where it helps to know a little bit about data science, knowing which algorithm to choose and why. I'll say more about that in a few moments, and I'll also introduce a cheat sheet that Microsoft put together so that even if you don't have a PhD in data science, you can hopefully choose a proper algorithm in order to build this model. Once the algorithm is selected, then you train and score the model. You basically let the machine learn from the input data and then score itself or evaluate the accuracy of the results using a separate data set that you provide for scoring. You'll see me do that in Azure ML Studio. In fact, rather than use two separate data sets, we'll take one set of input data and we'll divide it into two pieces using some of that data as input for training the model and the remainder of the data as output for scoring the model. Once we are satisfied with the accuracy of the model, and I'll show you in ML Studio how to determine exactly how accurate the model is, then we can deploy it. One of the cool things about ML Studio is that once the model is ready, with little more than a couple of button clicks, you can deploy it to the cloud as a web service. Then you can build applications around that model that use simple REST APIs to transmit data into the model and get data back out. You can code your own algorithms for use in Azure machine learning models if you want, but frequently you don't need to because it comes with some of the most commonly used machine learning algorithms already implemented for you. These algorithms appear as modules in the Modules palette in ML Studio, and applying one of them is as simple as finding it in the Modules palette, dragging it out and dropping it onto the canvas, and inserting it into the workflow. Now, the algorithms that are provided for you in the box fall into 4 basic categories. For example, there are algorithms for anomaly detection. Classic use for these is to examine credit card transactions to determine which ones might bear further scrutiny, which ones are potentially fraudulent. So imagine this. You train the model by feeding into it hundreds of thousands or millions of credit card transactions. You tell it which ones might be fraudulent. Once the model is trained and scored, then you take a new credit card transaction, feed it in, and it tells you whether that transaction might be anomalous or not. That is, whether it might need to be checked on by humans or fed into another machine learning model or something to determine if indeed it might be a fraudulent transaction. There are also algorithms for classification. These are used in spam filtering, among other things. You train a model by providing lots and lots of emails telling it which ones are spam and which ones are not. And then you can feed one email into the model and it will classify it as spam or not spam for you. Another very common type of algorithm used in machine learning is the regression algorithm. There are several different types of those. Linear regression is one that is used quite a lot. It's great at taking a set of inputs and predicting an output from it. For example, you provide it with data regarding a person, their age, their country of birth, other factors, their education levels, and it might try to predict their income level from that data. So again, you can code your own algorithms if you want to. In fact, Azure ML is 100% extensible in that regard. But the whole point of it, and the point of ML Studio, is providing most of the algorithms you're likely to need in the box so that you can simply apply them to the model without having to write any code. Choosing the right algorithm is something that requires both experience and expertise. And if you're not a trained data scientist, you may want to find someone who is in order to help you pick the right algorithm or algorithms for a model you're building. But to help out just a little bit, Microsoft provides us with something called the Microsoft Azure Machine Learning Algorithm Cheat Sheet. This is the latest version of it. They do update it from time to time, which is why I put its URL over on the right-hand side. This is a great place to start. If you're new to machine learning, you want to accomplish a given task like do credit card fraud detection or something else, and you're trying to decide not only what algorithm to use, but what class of algorithm to use as well. We're almost ready to open ML Studio and begin building a model of our own. But before we do that, I wanted to call your attention to this free ebook from Microsoft Press. If you're new to Azure Machine Learning or new to the science of machine learning in general, I think you'll find it a handy resource. It's well written. It has lots of examples, including examples that you can follow along with. It's a great way to get some additional background and to build the context that you need to do predictive analytics using Azure Machine Learning. Here's the process we're going to use to build a machine learning model. We'll start by loading a data set. I'm going to use one of the sample data sets that comes with Azure ML Studio, but I'll also show you how to upload data of your own to feed them into ML models. Then we'll do some pre-processing on the data. When we examine the data set that we loaded, we'll find that certain columns don't need to be included in the data that we pass to the model for training, and certain rows don't need to be in there either, specifically rows that are missing some values. So in ML Studio, we'll prepare the data so that we have a good clean data set to feed into the model to train it with. In step 3, we'll define the features of the model. In other words, we'll specify which values we want to be able to input to this machine learning model and which value we want it to output. That is, given our inputs, what is its predicted value for the output from those inputs. In step 4, we'll select an algorithm and we'll use it along with the data that we've prepared in step 3 to train the model. This is the fun part. This is why it's called machine learning, because Azure ML will do most of the work, and when it's done, it will tell us that the model is trained. Of course, at that point, we don't know how well it's trained. We won't know how accurate it is in predicting outputs. So in step 5, we'll score the model. We'll basically take the data set that we used to train it. We'll take a portion of that, which we broke off a little bit earlier, and we'll use it to score the model, to evaluate it, to see how accurate it is at predicting the values that we want it to predict. Once we're satisfied with it, then in the 6th and final step, we'll deploy it as a web service so that we can build applications around it by making REST calls to it, and we'll use a simple test harness provided by ML Studio to input some values and see what the predicted output is. The place to start with Azure Machine Learning is with the ML Studio. If you're following along with me, point your browser to studio.azureml.net. Now, you can either sign in with a Microsoft account or you can use guest access. I'll do the latter, and I'll choose my Microsoft account, and that should take me back to the ML Studio. It is asking me to log in, so I'll go ahead and do that. And then I should be returned to Azure ML Studio and given the opportunity to create a new experiment. I'm also offered the chance to take a tour. That's actually a pretty good tour. It takes 7 or 8 minutes to go through. Great way to get familiar with this environment if you haven't used it before. But of course, with the demo I'm about to do, you're getting a personalized tour. So if you want to come back and do that tour later, that's fine. I'll just click Not Now for now. Now, the next thing I want to do is create a new experiment. So I'll click Blank Experiment. And now we see the workspace in Azure ML Studio. You can see the modules palette over on the left. In fact, if you want to browse around here and just look at some of the different modules they make available to you, feel free to do that. We'll be using a handful of these, probably 7 or 8 of them in this demo. But the first thing I want to do is change this experiment name at the top. We'll just call it Car Prediction, because we're going to use a data set with a bunch of data about cars. We're going to train the model from that data set, and then we're going to use the trained model to predict some output values when we give it various inputs. So the first thing we need to do is get some data into here. Now, one of the things about this modules palette is that there's a lot of stuff in here. If you expand all of the items in the tree, it's a very, very long list of things. So an easy way to find a module that you want is to use this search box at the top. I'm going to type automobile. That'll filter that out some. And I see a sample data set here titled Automobile Price Data Raw. I'll just drag that out to the canvas here so that we can use it as our input data. Now again, I'm using a sample data set here, but if you wanted to upload a data set of your own, it's really easy to do. You just click plus new down here, do dataset from local file, and then browse to a local file on your computer so that it can be uploaded to the cloud for you. So, what does the data set look like? Well, an easy way to find out is to click this output port. That little circle at the bottom of the module is something we call a port. And as you'll see, modules have input ports and output ports. Sometimes they have multiple ports. If I click it, I can select Visualize. And the ML Studio will show me what the raw data looks like. Now, there's not a ton of data here. This is really used just for sample data to learn how to build a model and train a model and things like that. But each row in this input data set describes some features or characteristics of a car. For example, the engine location, the length of the wheelbase, and things like that. If I scroll over here to the right, we'll see a column called Price. Ultimately, this is the feature or value that we're going to do predictions on. In other words, we'll feed in values for some of the other fields, like engine type, number of cylinders, and we'll ask machine learning to predict for us what the price of such an automobile would be. The next step is to prepare the data so that we can use it to train the model. And to do that, I'm going to get help from a couple of the modules available in the modules palette, beginning with one named Project Columns. Now, the Project Columns module, which I'll drag out to the canvas here, is there so that we can take all of the columns in the input data set and filter out the ones that we don't want to use to train the model. So I'm going to connect the output from the data set to the input of the Project Columns module. I'll even move it to line it up a little bit better there. Notice that when the Project Columns module is selected, on the right-hand side, I see a button labeled Launch Column Selector. I can click that and specify exactly which columns I want to come through or which columns I want to be excluded. So I'm going to ask ML Studio to begin by passing all columns through. If I did nothing else at this point, all the data that's provided into Project Columns from the raw data set would come through as output as well. But then I'm going to select Exclude right here. And from the list of column names, this is all the columns in that input data set, I'm going to select one named Normalized Losses. One reason I'm selecting this to be excluded is that it doesn't have really any relevance to the predictive analytics I'm going to try to do. Also, if you visualize the output from the data set, again, you'll see that there are a bunch of missing values in that Normalized Losses column. So now, the output from Project Columns will be everything given to it from the input data set minus the Normalized Losses column. By the way, when you build large, rich, and complex models, sometimes you have dozens or even hundreds of modules out here on the canvas, and it gets a little bit hard to remember what each one is doing. So one cool thing you can do in Azure ML Studio is add comments to the modules. So if I double-click the Project Columns module, I can type in a comment like this. I'll say exclude Normalized Losses. That's that column that I'm excluding. And then, when I click out here, a little down arrow appears, and if I click it to expand it, I can see that comment that I added to Project Columns right there. So this is step one in cleaning the data, but we're not quite there yet. Again, one reason I excluded the Normalized Losses column is that it had rows that were missing a bunch of values, but the Normalized Losses column isn't the only one that has some missing values. If you look closely when I visualized the input data set, you may have noticed that the price column contains some missing values as well. We would like to exclude those because ultimately price is the column or feature that we're going to try to predict using our ML experiment. So I'm going to get some more help from the modules palette. I'm going to type clean over there and drag out to the canvas a module named Clean Missing Data. Now, when it's selected, there's a drop down here labeled Cleaning Mode. I'm going to tell it to remove the entire row. In other words, based on these values up here, any row that has at least one missing value is going to be removed from the data set that is output from the Clean Missing Data module. So let's connect the output from Project Columns to the input to Clean Missing Data. And if we wanted, we could add a comment here to make it easy to determine, if we're looking at this model later on, exactly what we've configured this Clean Missing Data module to do. So I'll say remove rows with missing values. Okay, and then I'll click that down arrow to actually show that. Now let's do something really important here. Let's save the model. It's not a bad idea to save the model from time to time. That way, if you mess something up and have to step back, you can recover it. It's also, sometimes you see people, they'll click the back button in the browser here, and they'll lose a bunch of the work that they've done. If you save the model, that's going to provide some protection against that. It doesn't prevent you from clicking that back button, but it does mean you can easily reload the model and get right back to where you were. So we'll do a save like that. And it has just been saved. When I go back to ML Studio, I'll see this car prediction experiment there, and I can easily open it just by clicking it. Now let's run the model. Let's see what happens when it runs. No, we're not going to see any output explicitly yet. We're not ready with a trained model to actually do prediction, but it does allow us to check that everything we've done so far is good. And if we want to see what the clean data look like, well, I'll click this output port here and select Visualize. And remember, the Project Columns module is excluding one column from the output, Normalized Losses. The clean missing data module has been configured to remove from the input any rows that have missing values. So when I look at this input, I should find that all the rows are intact, that none of them are missing values, including rows with no data in the price column. It looks like the data is ready now. It's structured, it's cleaned, it's ready to go into the model. So let's proceed to the next step. The next step is to define the features of the model. In machine learning, features are individually measurable properties of the data that you're analyzing. In the automobile price data raw data set that we're using here, each row represents one automobile, and each column represents a value or feature of that automobile. Identifying features for a robust and accurate predictive model frequently requires experimentation and domain knowledge of the problem you're trying to solve. Some features are better for predicting target values than others. For example, it's likely that there is some correlation between engine size and price because larger engines tend to cost more. But intuition tells us that miles per gallon might not be a strong indicator of price. In addition, some features have a strong correlation with other features, for example, city miles per gallon and highway miles per gallon. So we might want to exclude one of those, since having two of them adds little to the model. In this step, we're going to define the features of the model. In other words, we're going to pick the columns or fields that we're going to use for our predictive analytics. And specifically, we're going to use the fields named make, body style, wheelbase, engine size, horsepower, peak RPM, highway MPG, and price. And the way we're going to do that is fairly simple. In fact, there's nothing here you haven't seen before. We're going to get another project columns module and drag it out to the canvas here like this. And we're going to connect the left output of the clean missing data module to the input of the project columns module. Now, in the first project columns module we used, our purpose was to exclude a column from the data. In this case, we're going to use it to include columns, to tell it which columns or features of the model we're going to use for our predictive analytics. So let me just drag that over here. And then let's select it and go over to the right and click Launch Column Selector. Now, in my previous project columns module, I started with all columns, but I'm going to start with no columns here. I'm going to explicitly specify which columns that are being presented to this project columns module we want to feed into the model itself. So I'll start with no columns here, include, and then if I click in this field, sometimes a list will appear for you. Sometimes you have to start typing for the list to appear. So I'll do the make field, and there comes the list. And let's see, let's also select some of the others. So where is body style? Let's select body style right there. Also want to get wheelbase right there. And engine size and horsepower. There's engine size. Be nice if these were listed in alphabetical order. They're actually listed in the same order that they're listed in the data set itself, but there is horsepower. Let's add peak RPM also. We are assuming that all of these values will be indicators or might be strong indicators of the final price of the automobile. I want to add highway MPG, and finally price. We definitely need to input that into the model as we train it, because ultimately that's the value we're going to try to predict. So I've defined the features of the model, defined the columns in the data set that I'm going to use as input and output, not only when I'm training the model, but later when I provide input to it so it can do predictive analytics. So we'll click OK right there. And if you look over on the right, you'll see that when the project columns module is selected, it shows us exactly which columns are going to be included in that output. Now it's not a bad idea to save the model just in case we do something wrong or inadvertently click the browser's back button or something, so I'll do a save, and now I'm good. I could easily back up to where I was right here. Constructing a robust predictive model requires training and testing the model. We'll use part of the data set to train the model and another part of it to measure how adept it is at predicting automobile prices. But before we can train and test the model, we need to select a learning algorithm to use. As you saw earlier, Azure ML Studio builds a lot of different algorithms into the box so that you don't have to code those algorithms on your own. We're going to use a linear regression algorithm here. Before I do that, let's do a little bit of organizing here just so that we can easily fit in all the modules that we're going to add. So I'll just drag these around here and get them ready here. Under Project Columns, I'll move it over to the left. You can use a single data set for training and testing a model by splitting its output. And an easy way to do that is to use the split data module. So let's find it in the modules palette, then drag it out here. Then I'm going to connect the output from Project Columns to the input to split data. So when split data is selected, if you look over in the Properties pane on the right, you'll see that by default, the data passed into split data is going to be split 50-50 among the two output ports. We want to change that. I actually want to use 80% of the data to train the model and the remaining 20% to score or evaluate the model. So we'll change 0.5 to 0.8. Now let's scroll down just a little bit here. And let's go get another module from the palette, specifically the train model module. This is where things start to really get interesting, because this is where we're going to be training the model to allow it to do machine learning. So let's bring train model down to here. And now let's think about the algorithm that we want to use. We're going to pass in a bunch of discrete values, and we're going to ask for a value out, the price of an automobile. That's actually a good application for linear regression. So let's go over and find the linear regression module in the modules palette. It will help if we spell linear correctly there. And there we are, linear regression. I'll just kind of position that in right over here. And now let's organize these things just a little bit. Now watch this. Here's my linear regression algorithm. I'm going to connect it to the left input port of train model. So when this model is trained, it's going to be using a linear regression algorithm to do the training, to build a model. I'm also going to connect the left output port from split data to the right input port of train model. So train model takes two inputs. One, the algorithm that you want to use for training the model, and secondly, the data that you're going to use to train it with. So we've made a lot of progress. We're taking the input data, we're splitting it into two, we're feeding it into a train model module where the learning is going to be done, and we've selected and applied an algorithm, in this case linear regression, with which to train the model. You'll notice there's a little red exclamation mark in the train model module telling us something's missing, and when I hover over it, it says value required. That's because before we can run this, before we can train the model, we need to specify which field or feature we're going to ask the model to predict. So let's go over to the right hand side, click Launch Column Selector, and then choose the column that we're going to ask the model to predict. We're going to ask it to predict prices, so I'll select that column right here. When I check OK, that should cause that to go away. Now, just to be sure, let's save the model. And then let's run it one time to make sure we don't see any kind of errors in the output. When we ran the model just now, we actually trained the model, but we have no idea how well it was trained, how accurate the output might be. So we're going to fix that by going back over to the modules palette and looking for the score model module, which we can see right here. And I'll drag it out and just drop it in underneath train model. Now, this is important. We're going to take the output from train model and feed it into the input of score model. Now, you recall that when we added the split data module, we directed 80% of the input coming into this model to the train model module, but we left 20% of the output to do something else with. That something else is we're going to use it to score the model. So basically now, when we run this, the model will be trained, the output will be fed into the score model module, and then Azure ML Studio will determine how accurate the data is and show it to us. So let's save those changes right there. And let's run the model again. Shouldn't take it too long to run. And now let's scroll down just a bit so that we have a little bit of room to work with. Now the model has been trained and scored, but we really don't have any idea how accurate it was, what the result of the training and scoring is. So Let's visualize it. Let's select the score model module and then select Visualize from the drop-down menu that appears when we click the output port. And now we're shown the results of the scoring. Each row here represents one of the sets of input that the model was trained against. And out on the right-hand side you see the actual price of the automobile for that row, and to its right the price that was predicted by the model. So we can scroll up and down here and compare the price values to the scored label values, and we can get some feel for how accurate the model is. But in fact, there's a way to get better information than that. That better way is the Evaluate Model module. So let's go over to the Modules palette and type Evaluate Model so we can find that module. Then we'll drag it out to the canvas here. And I'm going to connect the output from Score module into the left input of Evaluate Model. Now let's save it just to be safe, and then run the model again. And once it's finished running, we should be able to get a more quantitative assessment of how accurate the model is. And we do that by selecting Evaluate Model and then asking it to visualize the results for us. And it's having to think about that for just a little bit. We'll wait till the little green dot stops spinning, and now we should be able to do a visualize, and there we are. So what are we going to see here? We're going to see an assessment of how accurate this model is at predicting automobile prices from the inputs that we provide to it. And there's several figures here. For example, there's mean absolute error, which is the average of absolute errors, where error is defined as the difference between the predicted price and the actual price. Coefficient of determination is another, and this is the one that we tend to look at to just sort of see a high-level summary of how good this thing is. You want a higher number. In fact, the closer to 1 the coefficient of determination is, the better. What it tells us in this case is that with about 91 to 92% accuracy, given inputs that define an automobile, this model can predict what the price of that automobile would be, at least based on the data that we provided to it for training and scoring. Now that we have a trained model, we can deploy it as a web service in order to interact with it programmatically. That way, you could build mobile apps or some other kind of apps that transmitted data to the web service and got results back from it, automobile price predictions in this case. Before you deploy it as a web service, you need to streamline the experiment for scoring. That involves creating a scoring experiment from your trained model, which removes unnecessary modules that are needed for training but not for scoring, and adding web service input and output modules. Fortunately, ML Studio makes this really easy to do. We'll start by clicking the Setup Web Service button or just hovering over it and selecting Predictive Web Service Recommended. Now, in a moment, you're going to see some changes made to the canvas. In fact, you can see things moving around right now. You can see that some new modules have been added, the Web Service Input module right here, for example, and the Web Service Output module right here. And the automobile price data, the data set that we used to train the model, has been grayed out because now we're going to be making calls to this web service, providing inputs to it, and let it return to us outputs, in other words, predicted prices. Now, you see two tabs at the top. Training Experiment is the one that you created. It's the model that you created in order to do the training and scoring. Predictive Experiment is the one that has been modified with web service inputs. You can see that in it, the train model module is no longer there. It's not needed in a predictive experiment because you've already trained the model. So what are we going to do next? Let's click Run. And with the run completed, we'll click Deploy Web Service. Now, in a moment, we're going to see a dashboard of sorts for this web service. And on that dashboard is going to be a test button that we can use to test it by providing inputs and finding out what outputs it would give us. In other words, we provide feature data, regarding an automobile, and it'll tell us what it thinks the price of that will be. So to do that, we're going to click the test button, and an input panel appears. And what I need to do now is add a bunch of different values to this thing. Unfortunately, it's a fairly long list. It's not just the features that we use to train the model, but all of the features in that data set. And I do have to enter them all. Otherwise, I'll get a library error when I try to run this thing. So let's just provide some inputs here. We'll say that the make is Audi, fuel type is gas, aspiration turbo. Oh yeah, I love turbo cars. Number of doors, let's just say 2. Body style, we'll say hatchback. And let's keep going down through here. We'll give it drive wheels, we'll say 4-wheel drive. Engine location, front wheelbase, I'll just pick a number here, 99.5. Do the same for length and width, 178.2. Just kind of making these up as I go. Width, we'll say 67.9. Let's keep going here. Next is height. For that, I'm going to enter 52. Curb weight, we'll say 3053. Engine type, overhead cam or OHC. Number of cylinders, we'll say 5. Engine size, let's say 131 cubic inches. And let's keep going. Fuel system, fuel injected. Bore, 3.13. Stroke, 3.4. Compression ratio, we'll say 7. Some of these aren't even going to factor into the analytics that we're doing here because we excluded a lot of these columns from the input. But again, at least right now, you have to enter all of these values right here. So we're almost there. Let's say horsepower, 160 horsepower. Maybe we should make that bigger to get a really, really fast car, but we won't worry about it for right now. City MPG and highway MPG. Price we'll leave blank because basically we're going to make a call to the model, which has been deployed as a web service. We're going to provide all of these other inputs, and we're going to ask it to tell us what price it would predict from that. So a call is being made to the model with all of the inputs that we just typed in, and results have come back in the HTTP response. If we click details here, we can find out what the results were. And here's the most important part right here. Based on those feature values that we input for that car, and based on the knowledge it gained when we trained the model using the data set, the model predicts that the price of that car will be $19,488. Now remember, it has told us through Score Model that it's about 90, maybe slightly more % accurate in predicting these values. So the actual price could turn out to be 19,000 or 20,000 or whatever. But what's really important here is that once we've trained the model, deployed it as a web service, we can easily use that little test harness provided when you click the test button and provide inputs and see what the outputs are going to be. Now here's something you may find interesting. It's pretty cool that we trained a model and we're using it, but you know what? We chose an algorithm, linear regression, and we really don't know whether other algorithms might have produced a better result. So there is an easy way in Azure ML Studio to experiment with different algorithms and to compare the results. Let's do a quick example so you can see what I mean. Let's go back here and get back to our experiment. Here's the model that we built, the one that we trained. We're just going to open it up and make some modifications to it here. So up there at the split data module, now you remember we added the train model module to the canvas to do the training. We took 80% of the data coming from the input and directed it into train model, and we also chose linear regression as the algorithm that we wanted the model to use. Let's do this. Let's add another train module to the canvas like this. We're not limited to one train model. We're not limited to one algorithm. If we have 10 train models, we can try 10 different algorithms as well. So let's choose another algorithm. This time I want to try Bayesian linear regression like this. And I'll drag it out here and I'll connect it to the left input of this train model module, just like I did with linear regression and the other module. Now, what are we going to do next? Well, we need to get some data into train model. In the first example, we took this 80% of the data coming from the left output port of split data and put it right in a train module. Well, I haven't told you this, but you can actually have multiple directions for those inputs. So we'll just take that same data and pass it over to the new train model module. Now, let's add another score model module, just like we did the first time around, so we can assess the accuracy of the Bayesian linear regression. So let's see here, score model right here. And I should be able to do this just so we can see the flow of things a little bit better. And I'll sort of duplicate over on the right what I had on the left. I'll take the output from this train model, put it into score model, and I'll take the 20% of the data that we were using from the input data set to do the scoring the first time around and direct it right over here. And just so those things aren't covered up, we'll do that. It's kind of cool how you move these things around and the arrows follow them. Now, here's the really cool part. I can take this output from score model and direct it to the other input to evaluate model like that. Now, just to be sure, let's save this. And then let's run it. We'll give the model a moment to run. Oops, I forgot to do something. Notice the red exclamation mark here in the new train model module. It says value required when I hover over it, so let's select it there and let's fix that. Oops, don't want to double click it. That's actually going to add a comment. What we need to do, if you recall, is specify what value we want it to predict. So where is that showing up? I don't want launch column selector. Yes, I do. So I need a single column name, price. There we go. That should cause that error to go away. Select it right there. And OK out of it, and indeed it goes away. Now we will need to run this again. So now let's run it. Should run this time, may take a few seconds to do this, but now we're actually training the model twice, once using a linear regression algorithm, another time using a Bayesian linear regression algorithm. And I could visualize the results there from the second score model, but since I fed that into evaluate model, once this is finished running, and you'll notice the little clock icons right here, I can't actually do anything yet. It's still working. There go the there's the indicator telling me that that train model module is executing. You can see it working its way down the tree. By the way, one question that I'm frequently asked when I demo this stuff is when you do run, does it run the entire model from top to bottom? Well, conceptually it does, but in fact they're doing some caching internally, so modules that have already executed and whose output is available don't actually have to be run again. So even though you don't have any explicit control over which parts of the model are running, you don't have to worry about it running up costs for you rerunning parts of the model. Now, I see green check marks everywhere. Let's look at evaluate model, and let's ask it to visualize the results for us. And unfortunately, even though it doesn't tell us which model each of these lines corresponds to, the first one is the results that it gets from using linear regression. The second one is the results that it gets from using Bayesian linear regression. And it appears in this case that using plain linear regression was slightly more accurate, around 92%, as opposed to 90.4% for Bayesian linear regression. So this is cool because I could continue adding models here. Experiment with different algorithms and easily figure out which one might give me the best results given the input data that I'm providing. Let's briefly summarize what you learned in this session. For starters, you learned how to go into ML Studio and create a new experiment. Then you learned how to import a data set. We used a sample data set that's available in ML Studio, but I showed you how to upload data sets of your own. It's equally easy. You learned how to clean the data prior to training the model. Specifically, we used two modules, one named the Project Columns module and another named the Clean Missing Data module, to remove certain columns from the output and to remove rows that have missing values inside them. Then you learned how to define the features of a model, how to identify the variables that you want to provide as input, and what it is the model is going to try to predict. In other words, what variable or variables will come back in the output. Then you learned how to train the model. You saw me add a train model module to the canvas, connect an algorithm to it, and then run the model to train it. We also learned how to use the score model module to assess the results of that training. We even learned how to compare the results of two models, or specifically the results of two algorithms in the same model, by basically duplicating the part of the tree that does the training and that specifies the algorithm, and feeding the output from two score model modules into the evaluate model module. I think you'll agree it's pretty cool stuff. And perhaps what's most remarkable about it is that I didn't have to write a single line of code to do this. Now remember, you can customize these models a lot more than I did right here. You could use R modules or Python modules available right there in the modules palette, for example, to insert your own R script or Python script. But I think what I would invite you to do at this point is to experiment, play with it. Select a data set, either one of the sample data sets or something that you have. Build a model around it, experiment with different algorithms, learn about the algorithms, do some reading to find out what algorithms are best at doing what, and see if you can't build a predictive analytics model similar to the one I built right here. The cool thing about Azure Machine Learning is that it truly does bring machine learning to the masses. You don't have to be a PhD data scientist. You don't have to be a developer. If you learn a few basic skills, you can build sophisticated machine learning models of your own.